surds and indices, right? They will definitely take care of this topic called as surds and indices. Now, the name itself says that surd. What is the meaning of a surd? Surd is nothing but an irrational root. That means any number which will not give you a rational number. Any number which will not give you a rational number. For example, root 3. For example, 4 power 1 by 3. It is not a rational number. For example, fifth root of 25 power 1 by 5, right? 25 power 1 by 5 is nothing but fifth root of 25. All these are nothing but surds. Indices, the meaning of indices, again, as you can see in the name, it is nothing but equal to whatever the power which you are raising. That means, suppose for example, there is a base called as a. Power is nothing but m. What is a power m? A power m is nothing but a into a into a into a. It is multiplied how many times? It is multiplied m times. That means instead of writing a multiplied m times, you can also express in terms of indices as a to the power of m. Surds and indices is what we are referring to, which is nothing but either it can be an irrational root which will not give you a rational number. That means, suppose for example, square root of 4 is something what I have. Square root of 4 is nothing but equal to 2. That is nothing but a rational number or a whole number or a natural number or whatever it is. So it is not an irrational root. So square root of 4 is not considered as a surd, right? Square root of 3. Square root of 3 will not give me, it will give me a value called as 1.73 etc. So that is considered as nothing but a surd, right? Surds and indices is what we are discussing. We will take some of the questions with respect to surds. We will take some of the questions with respect to indices, and we will keep solving those problems. We will understand more or less the basics of surds and indices in today's class, rather than going to very high examination level questions. We will take those questions also in our upcoming classes as we proceed with session 2, session 3, session 4 or whatever it is, depending on the number of complexity or depending on the number of problems we have solved in those particular each session. Now listen to this carefully, sir. I am damn sure that any person who is listening to this particular class would have gone through this particular topic called as loss of indices. This will be something which will be taken care of in our school days itself, maybe in 7th standard or 6th standard or 8th standard, depending on what kind of what do you say, like either it is ICSE, CBSE or whatever it is. So definitely you should have gone through all these loss of indices in your school days itself. Let us understand those loss of indices right now. Let us not go too much in detail about this loss of indices because you already know about it, but let us understand for some time what all the loss of indices which are present. The first basic loss of indices is a power m into a power n. That means if the bases of two parameters are same, if the bases of both of them are same, which is nothing but a and a, I will write the common base called as a, and if they are multiplied, then the powers should be added. So m and n are the powers. If the bases are multiplied, then the powers should be added. This is my first law of indices. Second law of indices, same thing I can say that a power m divided by a power n. That means I again have the same base a and a. So I will, instead of writing two bases a and a two times, I will write it only one time common base as a. And if they are divided, then I will subtract the powers. Initially, if the bases are same and if they are multiplied, I will add the powers. And then if the bases are same and if it is divided, then I will subtract with the powers. That is my second law of indices. Suppose for example, I have only one base, but this time I have two powers for the same base, a power m whole power n. This can also be written as if there are multiple powers, I can write it as the product of the powers, or I can also write it as a power m whole power n can also be written as a power n whole power m, because this also will give me a power n into m, which is nothing but a power m into n. Both are absolutely same, right? Both are absolutely same. These are all something which my students already know it. I want to repeat for my students. I want to revise them so that we will start with problems in the next 5 minutes. A power m whole power n. Again, if I put another power p, it makes no difference, because you put as many powers as possible and you will keep multiplying all those powers. So it is a power m into n into p, right? A power m into n into p. This is another law of indices. Suppose, for example, I have a power m, I have a power m, and the power of other parameter, that means the power of power is nothing but a number or a variable called as n. It is in the fractional form called as 1 by n. It makes no difference again, sir. I can still write it as a power m power n. It is a power m into n. Here n value is 1 by n. M into 1 by n. So it is m by n, right? It is 1 m by n. Whether the power is a fraction or it is a whole number, it makes no difference. Suppose, for example, just now we discussed a power m whole power n, a power m whole power n. This can be written as a power m power n. This is something which students will make a mistake, because they both are not equal. Very, very important point. This is where some of the students will make mistake. I will tell an example also after we discuss or list out all the laws of indices. Very, very important point. A power m whole power n is nothing but not equal to a power m power n. They both are not equal. That bracket, whatever extra bracket which we are putting, it really makes a lot of difference. It definitely do make a lot of difference in simplifying. I will take an example also in some time and I will tell it to you, right? Next, another law of indices. These are all extra laws of indices what I am writing right now, which need not be actually there. You can derive it whenever required, but I am just writing it. Suppose I have nth root of a, right? Suppose I have nth root of a. You can remove this nth root, write down that a, remove that nth root. If it comes to the right hand side, it becomes a power 1 by n. For example, if I have square root of a, if I have square root of a, it is nothing but a power 1 by 2. If I have fourth root of a, it is nothing but a power 1 by 4, and it follows, right? It follows. Same logic. Suppose I have nth root of a, right? Suppose I have nth root of a. For that, again I will write it with mth root, right? Again I will write it with mth root. This can also be written as this is nothing but mth root of a. These both are absolutely same, right? Mth root of a. I will prove it with an example also after I list out all the indices, right? Mth root of nth root of a is nothing but equal to mth root of a. These both are absolutely same. Similarly, can I say that if I have something called as nth root of a whole power n, if I raise it to the same power, nth root of a whole power n, it is something like square root of 4 whole power 2. It is nothing but square root and that power 2 will get cancelled, or in other words, it is 2 into 1 by 2, which is 1 in the power. So it is a power 1 itself. So remove this and cancel this. You will be left with a power 1. These are all something which you are already aware of, sir. I am just revising you people so that we will take it to our problems. Now, in our second example, in our second law of indices, we divided with a common base, right? We divided with a common base and we made the powers different. We made the powers different. Now, let us make powers as the same and we will have different bases. A power m divided by b power m. Powers is different. Powers is the same. Bases are different. A power m divided by b power m. I can write it as keep the same power m. See, keep in only one power m and write it as a by b. Right, and write it as a by b. Similarly, I can also say it like this. I can also say it as a by b whole power minus m if it is there. This is nothing but whenever the power is having a negative value, write this as 1 by a by b whole power m. This can also be written as b by a whole power m. Right? This can also be written as b by a whole power m. And probably other 2 or 3 which we can derive is, suppose if I can say that if a power x is equal to a power y, if a power x is equal to a power y, if the bases are same, ignore the bases, equate the power, then x will be definitely equal to y. If bases are same, ignore the base and equate the powers. Suppose similarly, reverse is also true. If bases are different, and if the powers are same, ignore the power and equate the bases. Both are absolutely true. And the last thing which I definitely want to know is a power 0 will be equal to b power 0, will be equal to x power 0, will be equal to 100 power 0. All these values will definitely give you one beautiful number. That number is nothing but 1. I hope the idea is clear. Idea should be very, very clear. These are all the laws of indices which probably might help us in our problem solving when we start taking the problems in future. Idea clear, sir? Kindly comment in the live chat. These are all something which is already known. Again and again I am telling you, today the first class is basically on problem solving with the basics. We will start with the basics, we will understand some easy questions, we will take it forward with our tricky questions of examination questions in our upcoming classes. So today also we will solve some very, very good questions, but we will concentrate more on little easy side today. Kindly comment in the live chat. This is a very, very important notation. 8th one, mth root of nth root of a is nothing but mnth root of a. Now suppose if I take this 6th notation, suppose I take it as 2 power 3 power 2. What is the meaning of 2 power 3 power 2? Can I say it as, this is nothing but 2 in 2 power 3 square. 3 square can be written as 3 into 3, right? So 2 power 3 power 2 is basically nothing but 2 power 3 into 3. Similarly, if I write included bracket, if I include it in a bracket, 2 power 3 power 2, the meaning of 2 power 3 whole square is 2 power 3 is multiplied twice, right? 2 power 3 is multiplied 2 times. A power m into a power n, it is a power m plus n. First notation whatever we have used here. So it is 2 power m plus n is 3 plus 3. 2 power 3 plus 3. 3 plus 3 is nothing but what? 3 plus 3 is nothing but 2 times of 3, right? 3 plus 3 is nothing but 2 times of 3. Observe carefully, sir. This particular value is giving me 2 power 3 into 3. This particular value is giving me 2 power 2 into 3. They both are definitely not the same. I hope the idea is clear. That is what I meant with the 6th key point. A power m whole power n is definitely not equal to a power m power n, right? So it is 2 power 3 into 3 in my first example, 2 power 2 into 3 in my second example. They are not equal. Idea clear, sir? They are not equal. Suppose for example, if I take this 8th notation, suppose let me take this cube root of 4th root of 2, right? Cube root of 4th root of 2. This 4th root of 2 can be written as 2 power 1 by 4, right? That is from my 7th notation I can write like that. 4th root of 2 is nothing but 2 power 1 by 4. Again, what is this cube root? cube root is nothing but power 1 by 3, right? Cube root is nothing but power 1 by 3. Now I can say that this is a power m whole power n, a power m into n. It is 1 by 4 into 1 by 3. This is 2 power 1 by 12, right? 2 power 1 by 12. 2 power 1 by 12 can be written as 12th root of 2. It is the 12th root of 2, and that 12 is nothing but equal to 4 into 3, or it is 3 into 4, right? 12 is nothing but equal to 3 into 4. That means, can I again say that whatever I wrote it here as the 8th notation, this is mth root of nth root of a is nothing but exactly equal to m into nth root of, or mth root of that same value a. Both are absolutely same. That is what I wrote it in my 8th key point. I hope the idea should be clear, sir. These are some things which might be helpful in our problems as we proceed. So let us understand what all is required to solve our problems easily, so that we will concentrate on those problems right now itself. I hope the idea should be very clear. Kindly comment in the live chat before we start solving the problems if it is clear till this point of time for you. Loss of indices is what we started with. Very important loss is what we discussed, but fortunately we already know all these laws from our way long childhood days. This is something which we are not learning for the first time. This is something which we have learnt so many times in our school days, and that is the beauty of learning from childhood days. It will not be a difficulty. That is something which I say it in most of my sessions. If you know the concept of solving problems from childhood days, if you know how beautifully a time and work problem should have been solved by using a concept of LCM, you wouldn't have faced any difficulty at this point, sir. Unfortunately, there we have not solved problems in a much more better way. We used formulas and variables, and we are struggling right now because of what the mistake we have done in the past. I hope the idea is clear. Listen carefully, sir. We will start with some easy basic questions on surds and indices. First question. Square root of 2 power 4, cube root of 64, fourth root of 2 power 8. I need to get this value. Find the value of this particular surd. Now, this can also be written as 2 power 4. I will write it as it is. Square root is nothing but power 1 by 2. It is power 1 by 2. One problem I am writing in detail. It is power 1 by 2. 64 I will write it as it is. 64 is nothing but 4 power 3. Right? 64 is nothing but 4 power 3. Cube root is nothing but power 1 by 3. And 2 power 8 I will write it as it is. Fourth root is nothing but power 1 by 4. Now, I also told you that a power m whole power n is nothing but a power m into n. So it is 2 power 4 into 1 by 2. You need not write all these things in the exam. I am writing for your understanding for first question. 4 power 3 into 1 by 3. 2 power 8 into 1 by 4. So in the power of the first term it is 4 into 1 by 2 is 2. 4 power 3 into 1 by 3 is 1. And 8 into 1 by 4 is 2. Right? It is 2. So it is 2 square plus 4 power 1 plus 2 square. Answer for the first question is 12. Easy question to start with, and it's a very easy question to start with. Very easy question. I hope the idea should be very clear for the first question. Second one, we will understand each and every basic question initially, so that it should not haunt in our difficult questions as we proceed with our classes. Second one, again a very easy question. 8 power 2 by 3 value I need to find. What is the value of 8 power 2 by 3? Now, 8 power 2 by 3 can be written as 2 cube power 2 by 3. A power m whole power n is a power m into n. 3 into 2 by 3. It is 2 power 2, which is nothing but 4. Easy questions we will understand initially, sir. Slowly we will scale up the level of difficulty. 8 power 2 by 3 is nothing but, it is nothing but exactly equal to 4. So sorry, sir. Next, third question, similar kind of question. 16 power 3 by 4. 16 power 3 by 4. Whenever you get 8, which can be written as 2 power 3. Whenever you get 16, which can be written as 2 power 4, or it is nothing but 4 power 2. Try to express with all these things, sir. Try to express it as square or some power of some base, right? So it is 4 power 3 power 4. So 4 square power 3 by 4. So this can also be written as 4 power 2 into 3 by 4. This is nothing but 4 power 3 by 2. But unfortunately, I still did not get a rational number, right, or a whole number. So 4 can be written as 2 power 2 whole power 3 by 2. I will directly do it. 2 will cancel here. You are left with 2 cube, which is nothing but 8. Sir, I will not express 16 as 4 square. Rather, I will directly express 16 as 2 power 4. Yes, that also can be done. I just did it like this for you to explain in a much more easier way. It is not in fact a easier way, it is a lengthier way. But still, I want to explain you each and every step how it is working on. I want you to first understand the application of law of indices in my easy questions before we scale up the level of difficulty. I hope the idea is clear, sir. Before we scale up the level of difficulty, first let us understand the application of law of indices. Suppose, fourth one, square root of 8 minus square root of 4 minus square root of 2. The only number which will give me a whole number is square root of 4. Square root of 4 value is 2. Square root of 8. Whenever you have a surd in the square root or the cube root or whatever it is, try to express it as a perfect square because it is square root. If it is cube root, try to express inside as a perfect cube, and so on. That means 8 can be written as 4 into 2. Sir, why 4 into 2? Why not 8 into 1? Because 4 is nothing but a perfect square. Square root of 4 can be taken outside as 2, and remaining root 2 will remain, right? Remaining root 2 will remain. That means square root of 8 is 2 root 2 minus 2. I will write it as it is, minus this root 2. This root 2 cannot be expressed as anything. 8 can be expressed as 4 into 2. But 2 can only be expressed as 2 into 1, which we will get the same number again as 2 itself. So write down as it is. So if I simplify, 2 root 2 minus root 2 is nothing but 1 root 2. So 1 root 2 minus 2 should be the final answer. Root 2 minus 2 should be the final answer. I hope the idea is clear, sir. Next, few more questions of laws of indices. Suppose, for example, suppose I have 16 power 0.16 into 2 power 0.36. Now, can I write it as this 2 is the base in the second number. So 2 can only be written as 2 power 1. 16 is the base in the first number. 16 also express it as 2 power something. Yes, 16 can be expressed as 2 power something. So can I say that 16 is 2 power 4 whole power 0.16 into 2 power 0.36. 2 power 4 power 0.16 is 4 into 0.16 is, this is 0.64 into the 2 power 0.36. In both the cases, the bases are same. Keep only one base. If they are multiplied, add the powers. 0.64 plus 0.36 is, it is 1. 2 power 1 value is 2. 2 power 1 value is 2. Similar kind of question. We will solve some 15 to 20 easy questions initially, sir. You need to wait for me to take extremely good tricky questions in my next few classes, including today's class, where I will take some of the good questions also, right? Do not be in a hurry. Do not think that all these questions only will be taken care of. Definitely more number of questions we will take care of. You know the kind of class I take it, you know the flow of class I take it. I will always prefer to come from the first step, so that I will reach all the steps very easily. Suppose 243 to the power of 0.16 into 243 to the power of 0.04. Now see here, again the bases are same. Write down the same base, 243 to the power of, if they are multiply, add the powers. 0.16 plus 0.04 is 0.2. Now what can I do from this? This is nothing but 243 to the power of 0.2. This is again something which we discussed in our fraction to percentages conversions in our percentages class and also DI class. 0.2 is nothing but, it is 1 by 5, right? It is 1 by 5. That means basically they are asking you what is the fifth root of 243. That means which number, when I raise it to the power of 5, I will get it as 243. 243 is nothing but 3 power 5. 3 power 5 is 243. So fifth root of 243 is nothing but how much? It is nothing but 3. 0.2 is nothing but 1 by 5. 0.2 is 20%. 20% is nothing but 1 by 5. Again, sometimes it becomes very easy for us by using fraction to percentage, which we have studied. You can never ignore that particular thing, sir. Suppose similarly, 256 to the power of 0.16 into 256 to the power of 0.09. Same logic again. I want only one base to be written. Write down 256, and because they are multiplied, add the powers. 0.16 into 0 plus 0.09 is 0.25. 0.25 is nothing but 25%. 25% in fraction is 1 by 4. So they are asking you fourth root of 256. What is fourth root meaning? That means some number is there. When I raise it to the power of 4, I should get it as 256. Which number, when I raise it to the power of 4, I will get it as 256? 4 power 4 is 256. So fourth root of 256 will be equal to 4. I hope you are able to understand the logic behind using surds and indices, laws of indices especially. Again one more similar question for our understanding. Suppose, for example, suppose if I take this 0.01024 whole to the power of 1 by 5. Now this can also be written as 0.01024. First of all, I will write it as 1024, and if I start from right hand side, 1 place, 2 places, 3 places, 4th places and 5 places. After 5 place I have a decimal point. So it is nothing but multiplied by 10 power minus 5 whole power 1 by 5, right? Whole power 1 by 5. 1024. Just a couple of days before, I took a concept called as last 2 digits, and I used this beautiful number called as 1024 also in last 2 digits, which is nothing but 2 power 10. 2 power 10 into 10 power minus 5 whole power 1 by 5. Can I write it as 2 power 10 whole power 1 by 5 is 2 power 10 by 5. It is 2 power 2. 10 power minus 5 whole power 1 by 5 is 10 power minus 5 into 1 by 5. It is minus 1. So it is 10 power minus 1. So answer is 4 into 10 power minus 1, 4 by 10, which is 0.4. Answer for this question is 4 by 10, which is 0.4. Slowly we will understand what are the next varieties of questions which might occur in our examinations. Next, similarly, your questions can also be in terms of negative powers. I told you already, a power minus m is nothing but 1 by a power m. A power minus 1 is nothing but 1 by a power 1. That means whenever I have a negative power, a power minus 270, if I have a negative power, if I need to make a positive power, so put it in the denominator, write it as 1 by that number in the positive format. Or if I have a positive power, if I want to make a negative power, put that again in the denominator and make it as a negative power. Again, if you see, if you cross multiply, a power minus 270 into a power plus 270. So common base is a. A power m into a power n is a power m plus n. Minus 270 plus 270 is 0. So a power 0 is nothing but 1 itself. Right? Again, it's the proof of one of the laws of indices. Right? Now see here. Suppose if I have a negative power, it makes no difference, sir. Suppose if I have 64 to the power of minus 2 by 3 into 1 by 4 to the power of minus 2, right? I have negative powers. 64 can be written as 4 cube. 4 cube to the power of minus 2 by 3 and 1 by 4 power minus 2. If I want to make it positive, so put it in the numerator in this case, because 1 divided by 1 by 4, that 4 will come above. So it is 4 power 2. 4 cube power minus 2 by 3. This 3 and 3 will cancel. You are left with 4 power minus 2. Next term is 4 power 2. A power m into a power n. A power m plus n. 4 power 0 is 1. I hope the idea is clear, sir. 4 power 0 value is 1. Excuse me. Next question. Next question. Listen carefully, sir. Suppose your next question is, I hope the idea is clear to everyone till this point of a time. Now see the next question. Next question is cube root of 2 into square root of 2 into cube root of 3 into square root of 3. This value I need to find. I need to find this value. Now again, can I say that cube root is there for this particular first term, cube root is also there for this particular third term. So what I will do is, powers are same, multiply the bases. That means I will write it as 2 into 3, right? I will write it as 2 into 3 and I will put a common power called as 1 by 3, right? Common power is 1 by 3 or it is cube root of 3, right? Cube root in fact. Similarly, again here it is square root, the last term is also square root. Again the powers are same. Power is nothing but 1 by 2 in both the cases. Multiply the bases. It is nothing but 2 into 3. Keep the common power called as 1 by 2. So this first term is 6 power 1 by 3. Next is 6 power 1 by 2. Now the bases are same, right? Now the bases are same. Keep only one base. And if they are multiplied, you should add the powers. Powers sum is nothing but 1 by 3 plus 1 by 2. You will get it as 5 by 6 in the power. Answer for this question is 6 power 5 by 6. Do not be in an assumption that in all our questions which we have solved earlier, most probably everywhere the answer was given or answer was coming as a whole number or a rational number or a natural number, whatever it is. In this case, you are not getting a natural number. There is no particular rule that you should always get a natural number, sir. Right? Answer need not be a natural number every time. It can be a surd also, like the way we got it right now. I hope the idea is clear. It can be surd. Answer can be expressed in terms of surd also. Suppose, for example, another question, 64 to the power of 2 by 3 into 2 power minus 2 divided by 8 power 0 whole to the power of 1 by 2. That means I am finding the square root of this particular value. 64 power 2 by 3 is 64 is nothing but 4 cube. 4 cube to the power of 2 by 3. That 3 will cancel. 4 square is what is left. 4 square is what if left. 2 power minus 2 is 1 by 2 square. 1 by 2 square divided by 8 power 0 is 1 whole to the power of 1 by 2. So this can be further simplified as 2 square is nothing but 4. It will cancel with one of the 4. 4 into 1 is 4. 4 divided by 1 whole power 1 by 2. 4 by 1 is 4. Square root of 4 is 2. Square root of 4 is 2. These are all very easy questions to take care of, sir. Very easy questions. And I believe that the idea should be very clear till this point. Yes, we have not moved on to tricky questions. We will not move on to tricky questions so soon before understanding other questions which can be solved. And then only we will move on to tricky questions. Next question. Next one. Square root of cube root of 0.004096. Square root of cube root of 0.004096. Now, can I say that 16 cube is nothing but 4096, right? 16 cube is nothing but 4096. Now, can I again say that because 16 cube is 4096, 0.004096 is nothing but 0.16 cube. These both are absolutely same. That means the cube root of 0.004096 is nothing but equal to 0.16. I will replace that with 0.16. Outer thing what is present is square root. Square root of 0.16. It is 0.4. Square root of 0.16 is nothing but 0.4. I am trying to connect the dots wherever it is possible so that it becomes easy for our upcoming problems. We will solve every variety of easy question initially so that we will take the next varieties of questions as we proceed with our classes. I hope the idea is clear, sir. 16 cube is nothing but 4096. Sir, how 16 cube is 4096? All those things we have already discussed in how to find the square of a number, how to find the cube of a number in our speed maths sessions. Suppose, for example, if your question is another question, if your question is 3 root 12 divided by 2 root 28, this divided by 2 root 21 divided by square root of 98, right? Square root of 98. Now listen carefully, sir. Everything keep expressing as a perfect square wherever possible. 12 is 4 into 3. That 4 square root is nothing but 2. Take it outside. You are left with root 3. Similarly, 28 is 4 into 7. Square root of 4 is 2. take it outside, you are left with root 7. This divided by, or if I convert this division to multiplication, this term will become reverse. That means numerator will come as root 98. Root 98 is 49 into 2. What is square root of 49? It is 7. Take that 7 outside. You will be left with 2 inside the square root. Divided by, keep this 2 as it is. Square root of 21 is nothing but, square root of 21 is nothing but, 21 is 7 into 3. So square root of 7 into 3, it is root 7 into root 3, right? It is root 7 into root 3. Simplify everything, what all you can do it. Can I say that this root 3 cancels? This 2 and 2 will cancel. What all you can simplify it, sir? Root 7 into root 7 is 7. 7 is cancelled with 7. So you are now left with, in the numerator you are left with 3 root 2 divided by, denominator you are left with 2 into 2, which is nothing but 4, right? Which is nothing but 4. If I further simplify, 3 into root 2 value, which will come later on, it is approximately 1.41. 3 into 1.41 divided by 4. Answer is approximately equal to 1.0605. Right answer is approximately equal to 1.0605. It all depends upon the answer options. If the answer option is expressed in this format itself, stop it, don't move forward. If the answer option is not expressed in that format, move ahead and continue with that particular simplification. It all depends purely on how the answer options are given. Excuse me. I hope idea is clear, sir. We are still in level 1 questions. We will continue to be in level 1 questions for the next few minutes. We will cover multiple varieties of questions as we proceed with our class. Jishnu, please repeat. Jishnu, every number I am expressing it as perfect square wherever possible. 12 is nothing but 4 into 3, Jishnu. This 4 square root is 2. I wrote it outside. Square root of 3 I cannot do anything. So I am keeping it inside the square root itself. Similarly, this 98 is 49 into 2. 49 square root is 7. 28 is 4 into 7. 4 square root is 2. This root 21. 21 I can only write it as 7 into 3. Both are nothing but not perfect squares. So I just wrote it as root 7 into root 3. Simplify, cancel everything, what all you can do it. And root 2 value we should know it as 1.41, which will keep repeating in so many problems in future. So root 2 I wrote it as 1.41. And I multiplied and then divided by 4 approximately to get the answer as 1.0605. Jishnu, I believe that it is clear, sir. I hope the idea is clear. Suppose another question. Suppose if 125 to the power of 2 by 3 into 625 to the power of minus 1 by 4 is equal to 5 power x, then find the value of x. If 125 to the power of 2 by 3 into 625 to the power of minus 1 by 4 is equal to x, equal to 5 power x, then find the value of that x. You need to find the value of that x. Now listen carefully. Same logic. There is no difference in the way what we are solving. These are all anyway very easy question. 125 is 5 power 3. 5 power 3 power 2 by 3 whole power 2 by 3. That 3 and power 1 by 3 will cancel. You are left with 5 power 2. Similarly, 625 is 5 power 4. 5 power 4 power minus 1 by 4. 4 and 1 by 4 cancel. You are left with 5 power minus 1 is equal to 5 power x. So 5 power 2 into 5 power minus 1, it is nothing but 5 power 1 is equal to 5 power x. powers are different, bases are same. So equate the powers. So x value will be equal to 1. Simple. Answer for this is the value of x is nothing but equal to 1. I hope the idea is clear. Idea clear, sir? Next few questions. I am sure that in surds and indices, you cannot escape from this term called as a plus b whole square. You cannot escape from this term called as a minus b whole square. Sir, why we cannot escape? Because usually we hate something called as a square root. Usually we hate something called as a cube root. That means whenever I have square root, I want to eliminate that square root. That will be my primary motto as long as I can eliminate it. There is no definite rule that every time a square root or a cube root will get eliminated in our surds problem, but we will try our level best to eliminate those square root or cube root so that we will get the answer in whole numbers. That is something which we like the most, right? That is something which we like the most. That means we will try to eliminate that particular square root or cube root. To eliminate square root, I should have square, because square root of 3 if it is there. If I want to eliminate this square root, I should have square term also. So that square root of square, they will get eliminated or nullified. You are left with only 3. Similarly, a plus b whole square, if I have it, if I have the square root for this, then the square root and square will eliminate and you are left only with a plus b. A minus b whole square under the square root will be a minus b. Similarly, a plus b whole cube under the cube root is, it is again a plus b. A minus b whole cube under the cube root is, it is again a minus b. That means we will try to eliminate all these square root or cube root whenever there is a particular chance for us, right? So definitely we need to know all these notations called as a plus b whole square, which is a square plus 2ab plus b square. A square a plus b, a minus b whole square is a square minus 2ab plus b square. And similarly, a plus b whole cube, a minus b whole cube. You might also need to know a cube plus b cube, a cube minus b cube. All these things we will come to it, sir. These are something which we have probably discussed in our algebra class. Now definitely those things also will be extremely useful, because these are some things which we have studied in our school days. I think it should not be a difficulty knowing all these things, right? Now see here, sir. Suppose for example, I have a question. Okay, let me write that exact question. Just give me a minute. I think I will write what is the question which is exactly there, rather than writing the question in a condensed format. I want to write that question whatever is exactly present. Just give me a minute, sir. Just a minute. I am trying to search the exact question rather than the question in a condensed format. Let us condense it. Okay, now see this question, sir. This is the question. This is the question which is there exactly. Your question is 6.5 into 6.5, 6.5 into 6.5 minus 45.5 plus 3.5 into 3.5. I need to find the value of this. Now You need not worry about these kind of questions. Whenever they give it like this, definitely this will be a square, right? Definitely this will be a square. So I can write it as 6.5 whole square. Definitely this will be b square. So I can write it as a plus 3.5 whole square, right? Plus 3.5 whole square. This is nothing but a square plus b square. Because there is a minus sign in between, it should be minus 2ab, minus 2 into 6.5 into 3.5. check it out whether this value is giving you 45.5. just check it out. Can I say that 2 into 6.5, it is nothing but 13, right? It is 13. 13 into 3.5, 3.5 is 7 by 2. 13 into 7 is 91, 91 by 2 is 45.5. Yes, it is absolutely satisfying the middle term. So can I say that a square minus 2ab plus b square, this is a minus b whole square. So it is 6.5 minus 3.5 whole square, which is nothing but 3 square, and value of 3 square is nothing but 9. So these kind of questions are also another varieties of questions which can be given in your examinations. But most of the time they will not give such easy questions, but we will understand easy questions initially. Suppose for example, another question, 7.5 whole square plus 37.5. In fact, the question is actually given like this. Question actually is 7.5 into 7.5 plus 37.5 plus 2.5 into 2.5, right? 2.5 into 2.5. This is 7.5 whole square. This is 2.5 whole square. This term should be 2 into a is 7.5, b is 2.5. Can I say that? Can I say that 2 into 2.5 is 2 into 2.5 is 5. What is 5 into 7.5? 5 into 7 is 35. 5 into 0.5 is 2.5. 35 plus 2.5 is 37.5, which is exactly what is there in the middle term. That means a plus b whole square. 7.5 plus 2.5 whole square, which is nothing but 10 square, which is nothing but 100. Answer for this question is 100. I hope the idea is clear. Answer for this question is, it should be 100. Questions sometimes can also be asked in that format, which we have understood right now. Idea clear, sir? Suppose this is another variety of asking a question. Suppose for example, I am sure that you should know this. A cube minus b cube is nothing but a minus b into a square plus ab plus b square. Similarly, we have a cube plus b cube is nothing but a plus b into a square minus ab plus b square. These are two things which we know from school days. Suppose for example, your question is like this, 0.05. It is 0.05. Let me take the exact question which is given, right? In the same format, let me write it, sir, so that you will understand how the questions are actually coming. 0.05 into 0.05. 0.05 into 0.05 again into 0.05. So 0.05 is multiplied 3 times, minus 0.04 into 0.04 into 0.04. That also is multiplied 3 times. Whole thing divided by 0.05 into 0.05, right? I believe that you are able to understand the question. 0.05 into 0.05 plus 0.002 plus 0.04 into 0.04. I need to find the value of this expression, whatever I have written. Now, this is nothing but 0.05 whole cube. This is nothing but 0.04 whole cube. That means first term is nothing but a cube. Second term is nothing but b cube divided by first term it b square, right? I will write it in the last term, b square plus is this nothing but what is 0.02? A value is 0.05, B value is 0.04, A into B value is 0.05 into 0.04 is 0.002. That is what is given in the middle. So this is AB value. If I simplify further, can I say that A cube minus B cube is nothing but A minus B into A square plus AB plus B square. That means I will get here as A minus B into A square plus AB plus B square. That term will cancel with the denominator term. You are left only with A minus B. A is 0.05 minus B is 0.04. Answer is 0.01. So you should definitely know all these things which we are studying in algebra to solve some of the questions in surds and indices easily. I believe that it is clear. A plus B whole square, A minus B whole square, all these are some things which you definitely need to take care of it. In fact, A square minus B square, all these are something which you need to take care of.
You can learn any subject, anywhere, any place and on the go. Come, let us go the other way in learning. Download our revolutionary app for free. ANC.